Okay, now let us answer question 8. So question 8 is coming from 2021 GCE, and the question reads, structure displayed below is the polymer that was formed from monomer Y. Name the monomer Y. Now, when you are naming, as you name the monomers, you can easily trace them like this. So I said the double bond normally, no matter how long the compound, always write it in the form where you find that the double bond, where the double bond is, whatever chain that is, whatever number of carbons that are extending, you write them as a groups, as groups, that is up and down. So which means you're only dealing with the 2 carbons. So check the 2 carbons if there's something repeating. So what I'm saying is that cut the polymer into 2 carbon, and see the repeating unit. Look at this. So in the first one, these 2 carbons, because this is where the double bond was. Okay, so you have how many carbons? 1, 2, 3, 4. What about this? 1, 2, 3, 3, 4. So you've seen the repeating carbons, huh? So when you cut it into 2 of the carbon in the long chain, that is the horizontal chain, you are going to discover from which monomer it is coming from. Okay? So look at this. 4 carbon, what monomer is that? That is called butene. Okay? Butene is the monomer from which these were formed. Now, if we were to write the systematic name of the butene that was involved, you find that it will be that is but dash 2-in. Okay, 2-in, because it was like this. It was like this. Carbon, then carbon here, carbon here. That is the reason why you are finding carbon here, hydrogen there, hydrogen. This is carbon, this is carbon, this is it, or there's nothing here. So this is the reason why you're finding them like this, because this whole was written down here, and this whole, this was written down here. Okay, so that is how it is. So please, the name of the monomers is called but1-in, or butene. Okay, so but2-in, not but1-in, please. but2-in, that is the monomer, or butene. So to be on the safe side, because what kind of butene was it? Okay, so B, name the monomer Y. Okay, what was the first one? Name the polymer Y, or name the polymer. So the polymer, please, is called polybutene. We've answered the question that we're not supposed to. So this one is called polybutene. So which means a lot of butenes are joining. Then what is the name of the monomer? Monomer is the smallest unit. It's called the butene, of which I said is but-2-in, because the double bond was at carbon 2. Construct the displayed structure of monomer Y. So monomer Y, that is when now you are going to know the importance of writing it like this, because you are going to know where the double bond is going to be. So in this case, it will be at carbon number 2. How do I know that it was at carbon number 2? Look at this. Whatever is breaking here, this was the double bond. So even here, this was the what? The double bond. Now look at this. We have 1, 2, 3, 4. So the double bond was carbon 2. The double bond is at carbon 2. So that is how you look at it. Okay? So how do you draw it? It will be like this. Carbon, carbon, carbon. So let me just put it here. Carbon, carbon, carbon. So 4 carbons. Between there was a double bond. Then here it was like that. Here like that. Hydrogen, hydrogen, hydrogen. This one needs a hydrogen there. This one needs a hydrogen there. Hydrogen, hydrogen, hydrogen. So this is the displayed structure of monomer Y. This one. Monomer Y was reacted with steam under the suitable conditions and organic compound Z was produced. So like I said, we've started now looking at just a repetition of what we've looked at. So monomer Y was reacted with steam. So immediate to hear of steam and immediate to hear of steam and alkenes, just think of what is formed is the alcohol. So in this case, we said the monomer is butene or but2-ene, which means the product will be what? Butanol, alcohol. Now, is it a question that we've been asked? No. The question is that to which homologous series does it belong? Compound Z. Compound Z is the one that is formed after hydration or adding of steam. So it belongs to what? Alkanos or alcohols. Okay? Alkanos or alcohols. That is where compound Z belong, because it was formed after hydration reaction. That is the formation of alcohol. Write the general formula of the series stated in C. Okay? So what is the series stated in C? We've just talked of alcohol. So the general formula of alcohol in short is CnH2n plus 1 with the OH as the functional group. This one is the general formula, okay, of alcohol, to which all alcohol conform. So that is something that you should know. Okay, so up to the 9th question, ethene, which is this one, is unsaturated hydrocarbon and it is manufactured from petroleum as shown below in the diagram. So the whole process of this, we are looking at the manufacture of what? Ethene from petroleum. Okay? Now, what are the questions? So as you can see, petroleum, it contains about several components, hundreds of them. So through process X, it results into what? Kerosene. Now, kerosene through process Y results into what? Ethene. Ethene through process Z results into what? Polyethylene. So what is prepared here? We are looking at ethene. Okay? Now, what are the questions that follows? Name the process Y and Z. Name the process Y and Z. So, for the sake of our learning, we are going to name process X, we are going to name process Y, and we are going to name process Z. Now, the process by which petroleum is converted to kerosene. So, kerosene is one of the products of petroleum that is produced, and this process is called fractional distillation. So, fractional distillation of petroleum or crude oil, that is what we call this. Okay, because these components that are found in this petroleum have different boiling points, and of course they have different boiling points. So that makes them possible to be separated by this process. Then what about Y? What is process Y? So the process by which kerosene is converted to ethene. Now, ethene, we can say these are small organic compounds. These are small compounds. Now, from larger one, which is kerosene, what process is that? You understand, or you should know that that is what? That is the cracking. Okay? Then now, from this one now, ethene, process Z now to polyethylene. So here there's a term poly to guide us. So you know that that is polymerization. Now what kind of polymerization? That is called additional polymerization. Okay? Additional polymerization. Alkenes or ethene are converted to polyethylene by the process of addition polymerization. Okay, so that is the process Z. Now, here, let us answer the questions now. Name the process Y and Z. So we've already named them. Y is the cracking, Z is additional polymerization. Describe either process Y or, describe either process X or Y. Include necessary conditions for a reaction. So here they've given us option. We can choose to describe process what? Process Y or process X or Y. And of course include necessary condition. Okay? So now, which one are we going to look at? So we are going to look at both. So Y we said is cracking. And where we are coming from, you know that cracking is just a process of breaking down large, heavier, and complex molecules into smaller ones. So here, we are going to describe, let us describe process Y first. Okay, Y, so which is cracking, since they are saying X and Y. So to start with, let us describe process Y, which is cracking. Okay. Now, cracking is just a breaking down of large and heavier complex molecules into smaller ones. Okay. What are the conditions? What are the conditions? So the conditions for cracking is that there should be a catalyst. So a catalyst. Now, what is the catalyst that is used in this case? Aluminium oxide. Okay. Aluminium oxide is used as a catalyst during the process of what? Cracking, or silicon oxide. Silicon oxide, which means this is catalytic what? Cracking. Okay. And of course, I'll put heat, okay, for thermal cracking. So the condition for catalyst aluminium oxide or silicon oxide, but for thermal cracking is heat. So these are the conditions. Okay. Then what about the other one that we can describe? The other one that we can describe, or X. What is X? So X, since we are saying X is fractional distillation, okay, so X is fractional distillation. Now, how about fractional distillation? So for fractional distillation, it involves the use of different boiling point. So the condition is temperature. Okay, temperature, that is the condition. Then for Z, polymerization, and of course the condition is temperature of 200 degree, and of course pressure of 200 ATP. So those, at least I've described all the three. Okay, so the other question here, that is question C. Ethene can undergo hydrogenation process with hydrogen. Write the reaction equation using displayed structure. So we are writing the displayed structure of the hydrogenation of ethene. So we are going to start with, that is ethene, writing it like this. It's presented like this. Okay, and bear in mind this is the smallest alkene. Okay, so we are adding hydrogen. You represent it like this. Then what is going to form? You know that an alkane is going to form. Okay, and that is ethane. So this double bond break, and of course room for attachment of two hydrogens, and therefore this one is going to become like this. Okay, hydrogen attaches hydrogen, and of course we are going to have what we call ethane. Okay, so hydrogenation conveyed hydrogenation conveyed alkenes into alkanes. So in this case, ethene into ethane. That is what forms. Okay, and that is the hydrogen. Now, what are the conditions? The condition UV light is one of the conditions. So UV light or high temperature. Okay, so if you are asked of the condition, UV light or high temperature is involved. And of course, the importance of this process, I think we've looked at the question at some point, but if you've forgotten, the importance of the process is of this process, that is hydrogenation. It is used in industry to convert, that is vegetable oil, or to hardening of vegetable oil